Have you ever wondered why boats, which are so big and heavy, float on water, but rocks, even tiny ones, sink? It's a mystery that puzzled scientists for years until they figured out the answer. To start understanding, imagine a boat. When you look at a big cruise ship, it looks like it should sink because it's really heavy. But here's the secret why it doesn't. It's all about buoyancy. Buoyancy is the force that pushes up against gravity. When you put an object in water, the water pushes back against the object. If the pushing force of the water is stronger than the pulling force of gravity, the object floats. If the pulling force of gravity is stronger, it sinks. Now, let's think about the rock. When you toss a rock into the water, there's not much water pushing back because the rock is dense and doesn't take up enough space. The rock is heavy for its size, so gravity wins in the tug of war and the rock sinks. On the other hand, boats are designed cleverly. Even though they're really heavy, they have a lot of space inside that isn't filled with anything, like air. That means a boat is less dense than a rock. Imagine a huge air balloon. It's easy to float in water because it has lots of air inside, which makes it light relative to the water it displaces. When a boat floats, it's because the overall density of the boat is less than the density of water. The large hollow part filled with air is what helps the boat keep afloat despite its weight. Archimedes, a famous scientist from long ago, discovered this principle and showed us that if the water weight displaced by the object is equal to or heavier than the object's own weight, then the object will float. This is called Archimedes Principle. So, next time you're at the beach and see a ship gliding on water or a stone sinking to the bottom, remember that it's all thanks to buoyancy and the magic that Archimedes discovered many years ago. Boats are built to use lots of space wisely, helping them float, while dense rocks don't have that advantage and splash right down into the water's depths.